Morning, my YouTube viewers. It is Crystal here. I'm here this morning because I wanted to make a machine learning model for you. And for me to do that, I had used Kaggle. So I went into Kaggle and I used their breast cancer classification data set. And I went ahead and made the algorithm and made predictions on it to do that. And the reason why I did this is because I've recently been diagnosed with breast cancer. And so because I've been recently diagnosed with breast cancer, I thought, well, this will be a good opportunity for me to work on a breast cancer data set. So obviously I'm going to be making a blog post on this as well. But enough about me and my problems. Let's go ahead and get on with the breast cancer classification. I got this from Kaggle. I got this data set off of Kaggle. And what I will do is I will give you a link to the notebook if you want to look at the code that I produced for it. And the first thing that we're going to do is we're going to make our problem statement. So the problem statement is predict if a breast tumor is malignant. And then what we're going to do is we're going to import the libraries that we're going to use to execute the program. So we're going to import pandas as PDs. So that's going to create your data frames and process your data. It's also going to create a series. We're going to import NumPy as NP. That's going to perform numeric computations and also create NumPy arrays. We're going to import OS, which goes into the operating system and retrieves the files we need. We're going to import sklearn, which is Python's machine learning library, which provides machine learning functionality. And we're going to import matplotlib and Seaborn, which gives you your visualization. So after we've imported our libraries, then what we're going to want to do is retrieve our files. And we're going to use OS to do that. So we've got one file called breastcancer.csv. We want to be able to view all of the columns in the data frame. So we're going to use pandas to do that. So it's going to be pd.setOptions brackets display.maxColumns, none. And so what that does is that allows you to view all of the columns in the data frame. We're going to read the file, and we're going to use pandas to read the file. df equals pd.readcsv. It's going to be the link to the breast cancer data set. And then so now we've got the data frame that we have created. And so you can see it's got 32 columns of data. It's got lots of data. And column 1, because remember in Python the first number starts at 0. So column 1 is your diagnosis. It's going to be either malignant or benign. So if it's malignant, you've got cancer. If it's benign, you don't have cancer. So now we're going to look at info. We're going to see what kind of data frame it is. So the ID is an integer, the diagnosis is an object, and the rest of the columns of data are float. We're going to check for null values, and we don't have any null values. That's going to be 0. We're going to remove the ID, and the reason why we're going to remove the ID is because Pandas automatically indexes each row of data, so you don't need the ID. It's already indexed. We're going to analyze the target, and we're going to use matplotlib to do that. So target equals df.pop brackets diagnosis. Data equals target.value_counts. Data.plot kind brackets kind equals bar, and plt.show. So what we do is we're plotting a bar chart, using Matplotlib to do that. And so you can see here that you have more benign tumors than you have malignant tumors. So now I just wanted to do a value count so you can see. So you have 357 benign tumors and 212 malignant tumors. And you can see here you've got either benign or malignant. And it did actually take me a while to figure out the best way to do this chart because I was trying to do it in a histogram. And whenever I did it in a histogram, it wasn't doing it correctly because malignant would have been 1 and benign would have been 0. And it got the zeros and ones messed up. So I ended up doing it as a bar chart. So we're going to create a heat map. And so core equals df.core and sns.heatmapCore. So we've got the heat map here. So you've got a heat map that has got, the features are varying between a low correlation and a high correlation. So what we want to do is, because you've got, I think, like 32 columns of data, we want to reduce that. So you've got core here that's giving you the correlation between these columns of data. So we've got 32 columns of data, and we want to reduce that with the hopes that it will improve the accuracy. So we're going to remove the features with a high correlation. So core matrix equals df.core.abs. So you're going to be getting the absolute value of the correlation. Upper equals core matrix dot where brackets np.triu brackets np.ones brackets core matrix dot shape comma k equals 1 dot s type is bool. We're going to find the features with a correlation greater than 0.9. So I know it says 0.8 because I used the code that I got from somewhere, but I wanted it to be higher than 8, so I made it 9. 2 drop equals brackets column for column in upper dot columns if any brackets upper column is greater than 9. So you're going to drop any features that have a correlation greater than 0.9. So we're going to drop the features. df reduce equals df dot drop, and then columns equals 2 drop. So we're going to print the original data frame, which is got 30 columns of data, and then we're going to print the reduced data frame, which has 20 columns of data. So what we've done is we have removed 10 columns of data with the hope that it would help our accuracy. So now we've got a new data frame with df reduced, and it is now 569 rows by 20 columns of data. So that's reduced the number of columns of the data frame. So we're going to define our dependent and independent variables. So y is your target and x is df reduced. And I decided in this instance I was going to standardize the data. Scalar equals standard scalar. X equals scalar dot fit transform x. And then we've got x after it's been scaled. So it has to be, after it's been scaled. So now we're going to use sklearn's train test split to split the data frame up into training and validation sets. And our test size is going to be 25%. So we check our shapes, and so now you've got X train, X val, Y train, Y val. So now we're going to define our model, and I decided just to try something that I don't use a lot. I decided to use a support vector machine. So CLF equals SVC brackets class weight equals balance comma, kernel equals RBF, comma, gamma equals auto, comma, random state equals 42, brackets, dot fit, brackets, X train, Y train, and then you've got CLF dot score, X train, Y train, and then so you've got 98% accuracy when you train your data. So now we're going to make predictions on the validation set. Y train equals CLF dot predict, X val, and then here's your Y pred, so you've got lots of benign and malignants. We check our accuracy. We've got an accuracy of 96.5%. And then what I do is I create a data frame of Y actual and predicted data. And so you can see the actual values and the predicted values. Okay, so what I have to do is I have to take YPRED and I convert it to a series. A series is like a data frame with only one column of data. And then we do a value counts on that, and you see you've got 86 benign and 57 malignant. And then now what we're going to do is we're going to create a bar plot of YPRED using the same algorithm that we use to visualize the target. So you can see you've got lots more benigns than you have malignants. So that's it. That's it for this. And so I went ahead and did this. And the reason why is because I've recently been diagnosed with breast cancer. And I'm going to have an operation. And I may or may not have to have chemotherapy and radiotherapy. So I thought, well, it's a good idea to go ahead and study breast cancer, since that's something that I can identify with now, whereas I couldn't identify with it before. And just to let you know that they picked it up on a routine scan. So I personally didn't notice any problems. I personally didn't find anything wrong. I didn't have any symptoms that I'm aware of. But it was picked up on a routine scan, and since it was picked up on a routine scan, now I've got to have something to do about it. So it's going to be a hard time for me for about a year, because I was looking on the internet and it said that when you have breast cancer, it's about a year of treatment. And so they say it's life-limiting. So that's what they say, you know. But I'll go ahead and keep giving videos as long as I can give videos. And I'll keep making blog posts as long as I can make blog posts. But obviously, it's going to be a little bit more difficult for me to do that. I've already had one thing that was shut off because I need to get my passport renewed. And with all this stuff going on with my health, I thought, well, I can't get my passport renewed until this business with my health is resolved. And so one of my accounts has been shut down because I couldn't get my passport renewed. So that was a bit of a bummer. But hopefully, when I get this health business resolved, I can get my passport and get that account sorted out again. I hope so anyway. So thank you so much for watching my video. If you like my video, please like and subscribe. And I look forward to making more content for you in the future. But I just wanted to let you know what was going on with me personally, with my health. So just so you'll know why I'm not making as many videos.